Warm welcome to our lecture. I am Manivannan, Assistant Professor in Department of ECE, Madanapalli Institute of Technology and Science, Madanapalli, Andhra Pradesh. First, I would like to express my sincere thanks to our management and MITS 90.8 radio station for providing e-content facility for this section. Today, we are going to discuss about Introduction to Microprocessor. So, in this lecture, flow of content. So, we are going to discuss about Introduction to Microprocessor and features of microprocessor, introduction to 8086 microprocessor, and general registers of 8086, segment registers of 8086, signals of 8086 microprocessor, and operating modes of 8086 microprocessor. So first we are going to discuss about introduction to microprocessor. So microprocessor is a program controlled or programmable semiconductor device. So microprocessor can give definition from the name itself. We can split the word microprocessor. So micro means small content, processor nothing but a device. When you are going to allotted some work to that processor, so work done a particular function within some microsecond is called microprocessor. So this is the definition from the word itself, from the name itself. Then the technical definition for microprocessor. So microprocessor is a program controlled or programmable semiconductor device. Program controlled or programmable semiconductor device. So microprocessor is multi-programmable clock driven register based semiconductor device. So without clock pulse, processor never functioning. So microprocessor is one type of programmable IC. So this programmable IC always perform when we are applying clock pulse to the device. So the microprocessor simply called clock driven semiconductor device. So what is the basic function of microprocessor? What is the basic operation of microprocessor? So microprocessor always accept hexadecimal value. Microprocessor always accept hexadecimal value. That is the basic operation of microprocessor. It has three basic functions: fetch, decode, execute. So what is the function of fetch? Get the value from memory. So fetch value always in hexadecimal. The second function, decode. So that is the fetch value converted into equivalent binary form. That is a decode operation. Decode nothing but convert hexadecimal into binary form. Then third function, execution. So it will perform the exact operation of the microprocessor. So these are all the basic operation of microprocessor. Fetch, decode, execute. Fetch, get the value from memory. Decode, convert hexadecimal value into binary. Then execute, perform the exact operation of the instruction. That is a microprocessor internal operation binary pattern, so that decoder unit is required. Then, what is the basic application of microprocessor? In general, we are using for the microprocessor simple application in calculator device, in account machine, game machine, child playthings, and instrumentation control, and traffic light control, and communication system. So these are all the various applications of microprocessor we used. Next one, microprocessor can fabricate different manufacturer. Most widely used manufacturer is Intel Corporation. So Intel introduced various microprocessor list given. So Intel introduced various microprocessor, that is Intel 4004, Intel 8008, Intel 8080, Intel 8085. So these are all the various microprocessor introduced by Intel Corporation. So you can classify this one for bit size. So what is the function of bit size? Means the processor can perform and accept process to perform ALU operation at a time the bit size. For example, 4-bit microprocessor can perform the ALU operation at a time 4-bit data. For 8-bit microprocessor can perform ALU operation at a time 8-bit data. For 16-bit processor can perform ALU operation at a time 16-bit data. So these are all the various microprocessor introduced by Intel Corporation. So that is in initial version lower 4-bit processor, then 8-bit processor, then 16-bit processor, 32-bit processor, then 64-bit processor. Like this, the microprocessor versions are upgraded. When processor bit size increased, automatically processing speed will be improved. Then when we are going to design our product with the help of microprocessor, the basic notations required. The basic terms in microprocessor. So bit called a single binary value, binary digit, either 0 or 1. So nibble, nothing but group of 4 binary bits. Byte, nothing but group of 8 binary bits. Word, nothing but group of 16-bit binary value. Double word, nothing but group of 32-bit binary value. So these are all the notations. In data, address, clock. So data, nothing but binary code operated by an instruction. So address we need for when we are going to access memory. So identification address, identification number required. So with the help of address, it is identification number for memory location. So address nothing but identification number for location. So clock nothing but the square wave. So clock pulse is required for the microprocessor because programmable IC. So all the programmable IC clock pulse is required. So required amount of clock pulse we need to apply through clock out pin to the microprocessor. Then only microprocessor is functioning. Then the microprocessor, we have the various types of microprocessor. Each microprocessor memory capacity will decide by the address line. That is memory capacity, internal memory capacity equal to 2 power n. So n nothing but number of address lines. For example, 8-bit microprocessor or 8085 microprocessor, 16 address line. So the memory capacity of 8085 2 power 16, that is equal to 64 kilobyte memory capacity. So memory, internal memory decided by the address line, 2 power n is the memory capacity of the processor. Then, so other terminologies required when we are going to design our product with the help of microprocessor, there is the bus concept and classification of bus. So definition for bus, group of conducting line. Group of conducting lines called bus. So we have the various classifications of bus, data bus, address bus, control bus, CPU bus, and system bus. So data bus nothing but group of conducting line that carries data. Address bus, group of conducting lines that carries address. So control bus, group of conducting lines that carries control signals like read control, write control, and etc. So all the control signals are carries through the control bus. CPU bus nothing but group of conducting lines that directly connected to microprocessor. CPU bus directly connected to microprocessor. System bus means group of connecting lines carries data, address, and control signals in a microprocessor system. So these are all the basic terminologies required when we are going to design or when we are going to design any product or system with the help of microprocessor. The above terminology is required. Now go for the introduction to 8086 microprocessor. So introduction to 8086 microprocessor. First we discuss about the features. So features nothing but each and every characters about 8086. So 8086 is one of the 16-bit microprocessor introduced by Intel Corporation. So this is the enhanced version of 8085 Intel microprocessor. So it provides 1 megabyte memory because in 8086 it has 20 address line. So 2 power 20, 2 power n, 2 power 20 equal to 1 megabyte memory capacity. So it has more number of 16-bit instruction, 16-bit powerful instruction. It can perform for arithmetic operation and arithmetic operation. So it support the 8086 can operate with two different mode of operation. 8086 can operate two different mode of operation. The one is maximum mode of operation, another one minimum mode of operation. During the design, when we are going to design any product or system with the help of single processor, that case 8086 we used for minimum mode of operation. When our system or product required multiple processor, that case 8086 can operate in maximum mode of operation. So like this, we are going to classify 8086 operating modes. Then, some other features of 8086 microprocessor. So the 8086 have instruction queue. It has 6 bytes. So with the help of instruction queue, you can prefetch the instruction. The prefetch instructions are initially stored into the instruction queue. So during the execution, the prefetch will provide fast execution. It has 16-bit arithmetic logic unit, more number of 16-bit registers, 16-bit general register, 16-bit segment register, 16-bit pointer register. So these are all the more number of 16-bit registers. So all the registers we can program, we can use it for programming purpose. It available in 3 versions. So 8086 and 8086.1 and 8086.2. So the 8086 is the one of the 16-bit microprocessor. So available in 3 version, only based on the operating frequency. So 8086 required 5 MHz clock frequency. 80861 required 10 MHz clock frequency. 80862 required 8 MHz clock frequency. So it uses, that is, in that microprocessor you can use pipelining technique for 2 stages. One is fetch stage, another one execute stage. During the fetch stage, we are going to include the pipelining process. With the help of during pipelining technique, you can prefetch the instruction and store into the instruction queue. During the execution stage, when you are going to add the pipelining process, you can execute parallel processing. You can perform the execution for parallel processing. Then, so it has 256 vectored interrupt. So it consists of approximately 29,000 transistors. So these are all the features of 8086 microprocessor. Now, we are going to discuss about internal architecture of 8086 microprocessor. So 8086 architecture or block diagram, nothing but initially 8086 has 40-pin dual inline package IC. There is a programmable IC. So inside 8086, we can divide 2 functional block. So 8086 architecture can divide 2 functional block. One is bus interface unit, another one execution unit. That is, you know the microprocessor operation, fetch, decode, execute. So with the help of bus interface unit, we are going to perform the fetch operation. So every fetch instruction stored into the instruction queue. Then another 2 function with the help of execution unit to perform decode and execute function. That is, fetch instruction, get it from BIU block, then transfer to decoder unit. Then after decoding, you can perform the execution, transfer through control unit. That is, our internal architecture can divide 2 functional block. One is bus interface unit, another one execution unit. With the help of BIU function, fetch the instruction from memory, then fetch instruction stored into the instruction queue. Execution unit to perform the other 2 functions. Then these are all the basic operation of BIU and execution unit. So bus interface unit fetch, that is, send out the addresses for memory location, because fetch means get the value from memory. When we are going to access memory, we need to give the identification address. So that is, we are going to send the addresses for memory, fetch the instruction from specific location, then read and write from the specific memory location, and send out addresses for I/O. That is, microprocessor can access with memory or I/O unit. 2 basic function. Microprocessor, you can access with memory or I/O unit. When we are going to access memory, send the addresses to memory and fetch from specific location, and to perform read and write operation from memory. When processor access with I/O unit, send out the addresses to I/O unit or I/O port, and to perform read and write operation from the I/O port. Then the execution unit function, the fetch value, execution unit get the fetch value from BIU block, then this will transfer to decode unit. So decode unit can convert its equivalent binary form. So after decoding over, to execute with the help of control signal, with the help of control unit to perform the execute operation. So this is the internal architecture of 8086. So we are going to divide 2 functional block. So one is execution unit, another one bus interface unit. So you know the principle of BIU, fetch the value from memory, store into instruction queue. Function of execution unit, get the value from instruction queue and decode, then perform the execution. Now, what are the major blocks of BIU? What are the major blocks of execution unit? So in general, fetch value initially in instruction queue, then get the data from queue, then decode and perform the execution. So various blocks of BIU, that is 4 number of segment registers and instruction pointer and instruction queue, 6 bytes of instruction queue, then address conversion mechanism. bus control logic. So these are all the major blocks of BIU. Similarly, in execution unit major blocks, 4 number of general register, 4 number of 16-bit general register, and 2 number of pointer register, and 2 number of 16-bit index register, then 16-bit arithmetic logic unit, 16-bit flag register, 16-bit temporary register, and control system. So these are all the various blocks of 8086 microprocessor. Now we discuss about each block functions. So first one, architecture were divided into 2 major blocks: bus interface unit, execution unit. Function of BIU, fetch the value from memory, store into the instruction queue. Execution unit, get the fetch value from BIU, then decode and execute the function. Now discuss about BIU function. So we have the 4 number of segment register. Total memory of 8086, 1 megabyte. The 1 megabyte memory, we are going to divide 4. We are going to assign the total internal memory, we are going to assign equally to the 4 segment register. So each segment register, we are going to assign 64 KB of memory location. So what are the segment register means? Code segment register, data segment register, extra segment register, and stack segment register. So our total internal memory divided into 4, assigned to each segment equal memory capacity. So what is the function of segment register during ALU operation, during programming period? So code segment, that is our microprocessor consists of 2 types of memory. One is program memory, another one data memory. That is our instructions access from program memory space, data access from data memory space. In code segment, that is instructions always store into the code segment register, that is code segment register. So code segment register also one of the 16-bit register. So it point address of start of code segment. So code segment register always combined with some base register. That is code segment always combined with instruction pointer. So instruction pointer is the default base register of code segment. So our instructions access from code segment register only. Then data segment register, also one of the 16-bit register. This general can used for data storage purpose. Whenever data exceeding 16-bit, in that case, whenever data exceeding 64 kilobyte, we can use for temporary data storage purpose. Data segment is also are using. So data segment register combined with some base register, combined with either SI register or DI register or BX or BP. So data segment default base register is SI or DI or BX or BP. That is address of data memory. For example, data segment combined with SI or data segment combined with DI or data segment combined with BX or data segment combined with BP, base pointer. So data segment default base register is any one of the mentioned registers. So stack segment, also 16-bit register, it point address of start of stack, point address of start of stack segment. The segment register always combined with stack pointer. Segment register always combined with stack pointer. So for 20-bit physical address calculation, our stack pointer combined with stack segment combined with stack pointer. For example, stack segment always combined with IP, instruction pointer. Then extra segment, also 16-bit register, point the address of start of extra segment. So data segment is 64 KB. When more than 64 KB can be required, that case, so extra segment also used for data storage purpose. So extra segment register combined with other base register such as like either SI or DI or BX or BP. So extra segment register combined with SI or ES combined with DI or ES combined with BX or ES combined with BP. That is, extra segment default base register is either SI or DI or BX or BP. So these are all the 4 segment registers used in 8086 microprocessor. So 8086 total 1 megabyte memory divided into 4 segment register. So segment registers also used for during program execution. During program execution, temporarily can perform the ALU operation with the help of segment registers. Then instruction pointer, also one of the important 16-bit register. This will address of start of next execution instruction. This is instruction pointer. Instruction pointer is the one of the special function register in 8086 microprocessor. So what are the special function means? So this will create a location in program memory space based on the instruction size. This instruction pointer is the memory pointer. It will create location in program memory space for the next instruction to be stored. So instruction pointer register always combined with code segment register. That is, instruction segment always combined with code segment register, CS combined with IP for 20-bit physical address of program memory. Next, so in that BIU unit, so another block, instruction queue. So instruction queue in 8086, it is a 6-byte of instruction queue. Store the opcode prefetch memory from the program memory. That is, a prefetch value always stored into the instruction queue. That is, in BIU and execution unit individually, BIU prefetch the instruction and store in instruction queue. Then execution unit take the instruction from BIU unit in queue to execute the instruction. So instruction queue 6 bytes. The function of instruction queue prefetch the instruction, and prefetch instructions are temporarily stored into the instruction queue. Then address conversion, that is address generation or address conversion mechanism. In 8086, it has more number of 16-bit registers. It has 20-bit address line and 16-bit data line. So address line notation A0 to A19. Using this 20-bit address, 8086 can address up to 2 power 20. This will produce 1 megabyte of memory capacity. So 20-bit physical memory address calculation with the help of address conversion mechanism. 20-bit physical address equal to segment address 16-bit multiply with 10, add with offset address. All the segment register combined with default base register or default physical address, default base register. For example, code segment default base register is IP, data segment default base register either instruction point, either SI, DI or BX, like this. So the 20-bit physical address calculation, segment address multiply with 10 and add the offset address. So we are getting 20-bit physical address. So the address conversion mechanism also included in BIU unit. So physical address calculation. So here we have the 4 number of segment register. Each segment register consists of 64 KB. We are going to assign the initial address and ending address between 5 zeros to 5F. In 8086, for addresses, general we are using for 16-bit address. So 20-bit address convert into 16-bit with the help of this address conversion mechanism. That is, each segment you can use the continuous addresses or you can start from some other location. For example, data segment we are using for 0 location to up to 64 KB end address. For example, 4 zeros to 4F. You can assign for next location for another segment or you can start from some other range. So now BIU unit principle completed. We go for the execution unit various block operation. So execution unit has 16-bit ALU. So this 16-bit arithmetic logical unit, it can perform 16-bit arithmetic as well as logical function. So 16-bit arithmetic unit can perform 16-bit addition, 16-bit subtraction, 16-bit multiplication, 16-bit division, and increment operation, decrement operation, etc. In 16-bit, logical unit can perform logical AND operation, logical OR operation, logical XOR operation, and rotate function, shift function, complement function, etc. So these are all the various functions of arithmetic logic unit. Okay. So this in 8086 processor, it can accept and process and perform ALU operation at a time. 16-bit data is possible. Then another blocks of execution unit, we have 4 number of 16-bit general register. That is register notation, 16-bit AX register, BX register, and CX register, and DX register. So these 4 16-bit general register. During ALU operation or during the programming period, this all 4 number of 16-bit register used for temporary data storage purpose. So AX is one of the 16-bit special register, special purpose register. So AX nothing but 16-bit accumulator, 16-bit accumulator. So accumulator is one of the special function register in microprocessor. So what are the special functions of 16-bit accumulator means? During ALU operation, it hold one data in accumulator, and during ALU operation, data transfer through accumulator. After ALU operation, results automatically load into the accumulator. So these are all the various special function in accumulator. So first function, during ALU operation, one data hold in accumulator. After ALU operation, results almost stored into the accumulator. During ALU operation, data transfer through accumulator. So these are all the various special functions of accumulator. So accumulator, you can split two 8-bit register, that is like AH and AL. AL nothing but 8-bit accumulator. AH is the higher byte accumulator. Then another register, BX register. So BX register is called base register. It's also one of the 16-bit register. During ALU operation, use BX register for temporary data storage purpose. For 16-bit operation, use BX directly. For 8-bit operation, you can split two 8-bit register like BH and BL. During 16-bit operation, use BX. 8-bit operation, you can use for BH and BL for programming purpose. CX register called counter register is also one of the 16-bit register. CX general used for counter purpose. So during ALU operation, whenever repeated function required, whenever counting function required, you can use counting purpose for CX register. Here also for 8-bit operation, you can split CX as a CH and CL. So CH and CL is the 8-bit counter register, counter lower byte and counter register higher byte. Whenever loop functions required, whenever count value required, can used for counting purpose CX register. So another one, DX register, also one of the 16-bit data register. During ALU operation, whenever additional data registers required, can use DX also used for data storage purpose. So DX can use for directly for 16-bit operation. For 8-bit operation, you can split DL and DH. In 8086, DX register specially used for multiplication and division operation. During the multiplication, after performing the multiplication, we have results and carry. So results automatically stored into the accumulator. So carry value automatically load into DX register. In division, results automatically stored into the accumulator. Quotient stored into the DX register. So DX especially used for multiplication and division. During multiplication and division, DX register used for higher byte output storage purpose. DX general used for higher byte output storage purpose. using for DX register. Then two pointer registers in 8086, that is stack pointer and base pointer. So both pointer registers are 16-bit registers only. So stack pointer we used for to access stack. In general, microprocessor have two type of memory, data memory and program memory. So this is a data memory means called stack and program memory simply called ROM or PROM. So whenever we need to access stack with the help of stack pointer. So stack pointer also one of the memory pointer. So it will point out the location in data memory space. It will create the location in data memory space. That is the function of stack pointer. Okay. Then base pointer, also another 16-bit register, is also used to store data temporarily in base pointer register. Then two number of index register in 8086, source index register, destination index register. During programming, suppose we need to create location for data loading purpose. Create the location with the help of SI register. So function of SI register, hold the offset address of data. Function of SI register, hold the offset address of data. That is, create the location with the help of SI register, 16-bit register only. With the help of DI register, also create the location for output purpose. DI register basic principle, hold the offset address of destination data. Hold the offset address of destination data. SI register, hold the offset address of source data. For applying data through SI register, for store the performing output, store the result into memory through DI register. For these two, for create the location in memory for both SI and DI register. Then 8086 has 16-bit flag register. 16-bit flag register. So flag register nothing but flag flip-flop. So in 8086 have 9 flags in 8086. So we have to classify the flag register in two category. One is conditional flag and status flag. That is, we have 5 status flag and 4 status flag. 5 conditional flag, 4 status flag. That is, in flag register is a 16-bit register. So bit patterns are assigned 0 to 15. Some bit positions are vacant, so we are not using the particular position. So the bit pattern for flag register already we assign for position 0 carry flag, position 2 parity flag, position 4 auxiliary carry flag, position 6 0 flag, position 7 sign flag, position 8 trap flag, position 9 interrupt flag, position 10 direction flag, position 11 overflow flag. So remaining positions are vacant, we are not using. Flag register size 16-bit, we have only 9 flags. So remaining bit positions used for future purpose. Now, during the program execution, after performing the ALU operation, based on the ALU result, the flag status will be varying. Based on the ALU result, the flag status will be varying. Now, what is the function of each flag? There is function of carry flag. After ALU operation, when we result will produce carry flag is set, otherwise carry flag is reset. Then parity flag, after ALU operation, when our result having even number of parity, even number of ones, then parity flag will be set, otherwise parity flag is reset. During the 0 flag, after ALU operation, our result becomes 0, then 0 flag is set, otherwise 0 flag is reset. Sign flag, the sign bit will represent sign bit will represent based on the sign flag notation value. Sign flag is 0, our data is positive, when sign flag is 1, data is negative. Then auxiliary carry flag. So auxiliary carry flag, during ALU operation, carry must generate from D3 bit, that is lower nibble. Carry must generate from lower nibble, that value passed on to next bit. Then auxiliary carry flag will be set. Otherwise, auxiliary carry flag will be reset. Then, so conditional flag we have 4: trap flag, interrupt flag, direction flag, and overflow flag. So trap flag set the processor when we are using processor enters in single step of execution. There is a processor execution, single step or multiple step of execution is there. When we are using the microprocessor in single step of execution, during that condition, trap flag must be set. Otherwise, trap flag is reset. In interrupt flag, whenever microprocessor wants to accept interrupt signal, must set the interrupt flag. Then only external interrupts are permitted in microprocessor. For example, during program execution, any interrupt came, microprocessor want to access the interrupt signal, we need to enable the interrupt flag. That is, set the interrupt flag. During program execution, microprocessor stop the program execution, this will respond the interrupt, then program execution will be continue. Then direction flag, generally used for string manipulation purpose. The flag is bit 0, the flag bit, the direction flag bit is reset or 0. String is processed being from lowest address to highest address. So string can execute from lower address to highest address. When the direction flag value is set or 1, set or logic 1, the execution from highest address to lowest address. That is the instruction execution by 1 by 1. So this will direction decided by the direction flag. When direction flag is set, execution from higher address to lower address. When direction flag is 0, the execution process from lower address to higher address. Then overflow flag. So this flag is set, overflow will occur. That is whenever data size is exceed. The result is more than data size. Result is more than data size. Then overflow flag will be set. Otherwise, overflow flag is reset. So these are all the various flags in 8086 and flag functions or principles. After ALU operation, our flag status will be changing. Our sequential flows status will be changing. So these are all the functions of flags. For example, we are taking one arithmetic operation, that is 8 9 add with 7 8. So after addition, we are getting output. So our data 1 8-bit value, data 2 8-bit value, result will produce extra 1 bit. Okay, that is our 8-bit, lower 8-bit is the result. Whenever data size exceed, that is the carry. So according to this result, our flag status will be varying. Our sign flag value, because sign flag result is not a 0, so sign flag is reset, SF value 0. So here carry will produce, according to this operation, carry will generated, that's what carry flag is 1. Then auxiliary carry flag, so our fourth bit, that is our nibble, fourth bit will generate the carry, that carry passed on to next fifth bit. When carry generated from fourth bit, immediately auxiliary carry flag value set condition, that's what AF also 1. Then 0 flag, result is not a 0, that's what 0 flag is reset. Then parity flag, when the result having even number of ones, then parity flag is set. So here odd number of 1 is there, that's what parity flag is reset, that is 0. Then overflow flag, here data size will be exceed, that's what overflow flag also 1. That is sign flag, our MSB bit, that is a position of MSB 0, that's what sign flag is 0. Then carry flag is, carry will generated, carry flag 1. Carry from D3 bit, that's what auxiliary carry flag is 1. Result is not a 0, 0 flag is reset. our result is not a even number of ones. That's what parity flag is reset, 0. Our result data size will be exceeding, the overflow flag is 1. So based on the ALU result, our flag status will be varying. So next one. So these are all the architecture of 8086 and various block functions. The next one, this 8086 microprocessor signals. So 8086 microprocessor 40-pin dual inline package IC. So it has the 40-pin IC. So here most of the signals are bidirectional. Most of the signals are bidirectional. So here signal number 38, signal number 32, 33 to 38, signal number 33 to 38 multifunction. We have multifunction. So now 40 signals of 8086. We have discussed about what is the signal rotation and what is the function of each signals. So here, so the signals you can divide address bus and data bus and control signal like this. That is, in 8086 can operate in two different mode of operation. So what are the common signal for 8086? What are the common signals for operating both mode of operation? And what are the minimum mode of signal only? What are the maximum mode of signal only? So I'm going to discuss like this. So signal classification. What are the signals common for both mode of operation? What are the signals used only for minimum mode of operation? What are the signals used only for maximum mode of operation? Like this I'm going to classify. So here it has the 20-bit address line, 16-bit data line, and we have the various control signals. So I'm going to discuss like this. So here first go for the multiplexed address data line. Multiplexed address data line. So in 8086, 20 address line, 16 data line. That is lower 16 address line in 8086, lower 16 address line combined with data line. So this will produce multiplexed address data lines. That is AD0 to AD15. Lower 16 address lines combined with data line. This will produce multiplexed address data lines. The notation AD0 to AD15. Then remaining address line A16 to A19. Remaining address line A16 to A19 combined with status signal. Remaining address lines are combined with status signal. So this will produce multiplexed address status signal. That is our multiplexed address data line signal number from 2 to 16. That is signal number 16 is AD0, signal number 15 AD1, 14 AD2. So these are all the multiplexed address data lines. So what is the function of multiplexed address data lines? So the signal, these complete 16 signals you can use for address as well as data purpose. But we cannot use at a time for both function. Okay. So with the help of control signal ALE, signal number 25, so function of ALE, this will separate the multiplexed address and data lines. When ALE is enabled, the complete 16 lines AD0 to AD15 can used for address purpose. When ALE disabled, ALE value 0, that case the complete 16 lines used for data purpose. So most of the signals are bidirectional and multipurpose. Automatically you can reduce the signal numbers. Automatically signal number reduced means our chip size also reduced. Okay. So this is the function of address bus. When ALE signal is high, the complete 16 lines used for address purpose can use complete 16 lines for address purpose. When ALE is 0, the complete 16 lines used for data purpose. That is multiplexed address data lines used for both address as well as data function, but at a time we can use any one function only. This is the function of multiplexed address data lines. The next one, control signals. So here we have read control signal, write control signal, memory/IO signal, and data transmit / receiver, data enable. So these are all the 6 control signals in 8086.